YouTube, it's Chris. Welcome back to the channel. This video is overdue. I'm going to show you guys how you can build your own custom DIY latency tool. Now I have had this quite a few years and it's broken on me recently, so now's a really good time to build a new one and document me building it and show you guys how you can do it yourself too. Now quite a few years ago, Pee-wee, shout out to him, go check out his channel. He built one of these and then he improved upon it and then sent it to me. And then since then, I've sort of played around with it and improved upon it and mucked around with the configs. I've had full permission from him to reverse engineer it and share a guide. And I will be providing that guide in this video and also on GitHub and documenting myself building it. And I will try to dumb it down for you and even for myself, as I'm not very competent when it comes to electronics, how you can actually build and make your own. Now, if most of you guys are playing a game that has a reflex built into it, you're just better off using the FrameView app. It will measure end-to-end system latency, excluding the mouse and the display. But if you're after a solution and you don't have an NVIDIA card or you don't play a game with reflex, or you actually also want to get your display latency, and you also want to include your mouse latency, this will be the tool for you, and I'll walk you through it. Now I've drawn a real basic, simple diagram here. Let's zoom in, just to make it easier for everyone to understand if you're not very electronic competent, kind of like I am. So I've dumbed this down. Well, basically how it works is this board will control everything. We've got a reset button and a start button to start measuring latency, a photoresistor that's connected to the display, and then a display to show our latency measurements. We have a transistor for a switch. We've got a resistor switch, and then this is soldered into our actual mouse switch. So we get full end-to-end system latency, including your mouse delay, monitor delay, everything, which is really cool. Now it will also include the delay of the Leonardo board as well. But generally speaking, when you use a tool like this, you want to be testing one setting versus the other, not necessarily worrying about the complete throughput latency, because this board has some processing delay as well. In the future, I might look at updating this tool to a better photoresistor and a better board, like a Tiny 4.0. But for now, I'm just going to stick with what I know what works. So let's go through the parts list here. Now, unfortunately, I'm in Australia, but I'll do my best to send the links so you guys in the EU, NA, or the Arabic states, you probably might have a bit of a hard time getting some of these. So all the best. Now we need a Leonardo board. Here's what that looks like. About $40 Australian. We need a transistor. This is what that looks like. We need a resistor. That's 220 ohms. This is for the mouse switch. Same with the transistor. We're going to need OLED displays to show us the actual latency values. What's great about this tool is that it's all external. It doesn't rely on software. I have seen latency tools out there that rely on software, and the software actually affects performance. So this thing's pretty cool. We'll actually need two of these. We'll need the photoresistor module. Now, unfortunately, I couldn't find this on Mouser, so I could only find this on eBay. So good luck finding that, but if you just search the part number, you guys should be able to find it. We need a latching push button. We could just use a switch here, but this is kind of nice because you push it in and it stays, and then you push it again. So you push it in once, it'll stay on, and then you push it again and it'll go off. So it's a latching push button. A little bit dear, 32 Australian dollars, but sort of the best one I could find on here, as far the cheapest one I could find on here even. We're going to need a push button. So this is just to reset the latency values if you want to start with another run, right? Another test. We're going to need jumper wires. Here's jumper wires for a Leonardo board. We shouldn't need to do too much soldering, but we will need to do a little bit, especially if you want to include the mouse switch, the mouse latency. I have made quite a few different configs on this. So there's a way to use this whole thing if you want to use it with the mouse switch, where it will auto click the mouse for you, and the Leonardo board doesn't even need to be connected to the PC at all. It can be powered externally, especially for games that have anti-cheat, that do not like boards like this plugged into the PC. Some anti-cheats are a little bit like that. We're going to need a 3-pin connector. That's mainly to connect to the photoresistor, just to make our life easier so we don't have to do too much soldering. So it's kind of like a 3-pin jumper. We're going to need a micro USB cable because unfortunately the Leonardo does not come with a micro USB. Now the rest is kind of up to you. I'm sure some of you guys will have stuff lying around, but you are going to need a soldering iron for a couple of things. You'll need some solder. You'll need a multimeter. I have a really cheap one like this. Doesn't need to be anything too fancy. Mainly to measure the mouse switch on the mouse and make sure that we're actually getting a reading. We're going to need wire stripper. This is a really horrible wire stripper. This is what I have at the moment. You guys could probably get a better one, or you might have one lying around at the house. We need some heat shrink just to clean up our old wiring. We don't want to leave anything exposed. Double-sided gel tape. So this stuff isn't too bad. You want to get the gel, not too sticky tape. And if it is super, super sticky, you can kind of put your fingerprints on it a couple of times to sort of loosen it off. This is mainly to sort of tape the photoresistor switch to the monitor while you do the latency tests. We're going to need a glue gun. Well, some of you guys probably won't need this, but I'm going to need this because I'm going to be putting it in my custom 3D printed module. You guys see me this, so you guys don't have to actually get the glue gun if you don't want, but I'm just including everything here. Some glue sticks, and then find a mouse that you don't need in the house. At the moment I have a Superlight lying around that I do not need, but it has to be non-optical switches. And because I'm using a Superlight here, we're going to have to use the wired mode, mainly for the earth. Got to do with how the mouse switch works here. Now, as far as the 3D printed base, I genuinely have no idea when it comes to 3D printers. In the future, if any of my viewers or followers or GitHub users that follow the guide and build one of these are able to make one of these, and you know, send the 3D print file so I can share it with everyone, that would be awesome. But for now, we're just going to have to kind of build it raw and have it outside of something like this, which isn't a big deal. I mean, we could still just use that. It's a real shame that NVIDIA don't sell an LDAP to just general users. Then we probably wouldn't need to really build something like this, but it is a lot cheaper being able to build something like this. So that's really cool. I will go ahead and start ordering all of these parts, and I'll start putting this guide on GitHub, and then I'll start recording the process of me building it. And wish me luck, guys. I'll see you soon. All right, here's my old Latency Tool that's built in its little 3D printed box, and it's connected to the mouse here. The mouse will be connected to the PC, and then the actual Arduino board, the Leonardo board, is actually connected to power over there. And I just have a camera here set up just to show you guys the values if I ever need to do an external tool test. So that's sort of what that looks like. And there's a cool little 3D printed cover to cover the sensor for the flash. All right, so everything came in the mail today. So I've got everything ready laid out on the bench. We've got scissors, wire strippers. I've got a screwdriver, mainly for the mouse, to take the mouse apart. I've got some spare wire just in case. We've got the double-sided clear soft tape, multimeter, got a razor blade, some electrical tape, heat shrink. We have the light sensor, the Leonardo board. We've got the display panels. We have the reset switch. It's just a little reset switch just to reset the values. And this is the toggle switch, so that'll be on to start doing the tests, and that'll be off. And then we have some 3-pin connectors for the sensor, and we have some cables so we can do less soldering. The 220 ohm resistor for the mouse switch, because the mouse switch is, I believe, 3.3 volt, not 5. And then a transistor for switching the mouse switch to toggle on and off from memory. So you don't have to sit there manually clicking the mouse to do each test. I do have a config where you can, but that's just annoying that way.
We have some solder, soldering iron, glue gun, which you guys probably won't need because you guys won't have a 3D printed little box. And yeah, that's everything. So let's get started with building it. All right, let's start with the screens. SDA is going to need to go to pin 2, and that's on both. So we'll do yellow for that. I've got both of these to SDA. I've got that to pin 2. Now I'm going to need to strip this wire and solder that into there. Because the wire is really thin, what I decided to do is use a razor blade to strip that back. And then I've just cut this one here and I'm going to solder that to there and use some heat shrink to go over it. I've wrapped the wire around that area and now we're ready to solder. I'll push the heat shrink over there. I cut it a little bit because it was too long. And then just pushed it over these two just a little bit. And now I'm going to use a lighter to light this up and then shrink the heat shrink. All right, so that's what that looks like there. So we've got SDA to pin 2. So now we need to do the same thing for a couple of different ones. For the green, which is SCK, we're going to need to do exactly the same method to pin 3. With the red, which I believe is power, which is VDD, we need to do the same thing for that, which is to VIN. And then black, which I believe is earth or ground. Yep, ground, GND. We're going to do the same thing for that, and we're going to probably slice in a couple of different things too, but we'll worry about that later. That's going to go straight to ground. All right, this is what it looks like now. We have the red from VDD to the VIN, and then we have the green to SCK and to pin 3. So that's what that looks like at the moment. Now it's time to do the ground. All right, so that's the earth that I've done here. It's a little bit messy, but we've got earth ground from here. This is going to go to one of the switches. Earth to here, and then I've actually ended up just using some wire that I had because we're going to need to extend this out for earthing a couple of different things. Mouse switch, transistor, and the start button. So that's what it looks like there. Now let's do the photoresistor. For the photoresistor, we've got black, red, blue. So we'll just plug that into this here. I'm unhappy with the color of the white, but it's not going to matter. This isn't going to be long enough because this is going to need to reach all the way to our monitor. So I'm going to have to use this wire that I have here to extend it and make it fairly long so I can actually reach it to my monitor. So I'll show you guys what that will look like. I want to make it like the same length as this. So what I'm going to do is I'm actually going to get this wire, roughly measure it out, and then I'll cut 3 wires to the length of that. So hopefully this is making a little bit more sense. See how we've got, if I can get the camera to focus, black, red, blue. So we've got black, red, white. These are the extenders. And black, red, blue. So I'm just going to solder that to that, that to that, and that to that. I did learn with my crappy wire stripper, I can actually strip the middle of the really short wires, the lead wires. It does work, but I had to use the very end there very carefully. So that part there where my thumb is. But yeah, no, it did work. So I was able to split these ones much easier than using a razor blade. All right, so this is kind of what it looks like. We've got the photo diode here in the connector with a bit of an extension cable. We got blue, black, red. So we're going to put blue into A3. We're going to put the red one into the 5 volt and then the black one into another ground, but I'm just going to put it in the ground here because there's another ground here and it's a little bit easier with the cable. So that's what it looks like here. That plugged in, red to the 5 volt, black to the ground, and the blue to A3. Now it's time to wire up our reset button. We're going to need a brown and a black one. The black one just goes to earth. The brown one needs to go to, the camera will focus, it's pin 8. This on-off switch is actually a little bit small, so I think I'll just go use one of the switches that I have from my already external tool. This is sort of no good, so it's a little too small. It's going to be too annoying to solder to. Call me a sucker for punishment. I decided to just do it anyway. I guess I wanted the challenge. Not the greatest job, but it'll do. So earth's just gone into earth, and then the brown has just gone into pin 8. All right, time to do the start button. We just have an earth, and we'll just tap into there. And then we also have a blue, or got turquoise there going to number 9. So there's my switch there. I've just cut it, made it a little shorter. Earth is going to go into here, and then the blue we'll put on the other one, and that'll go to the number 9. Just a word of advice, when it comes to stripping the wire, I generally like to just like kind of wind up the tips to just make it easier to solder. And then if I'm soldering 2 tips together, I like to just sort of like loop them over each other before I start the soldering job. All right, that's what it looks like in. Our little start button. So we push it once, it stays in. It'll keep doing the test. Then we'll push it again and it turns off. Right, on to the transistor, which is to toggle the mouse switch. So the mouse switch is actually going to be simply wired to mouse 1. We're going to need black for earth, purple for number 7, and grey for number 10. There it is here. I've got it ready to solder. All right, we've got the transistor in. There it is there. Earth, purple, and then grey. All right, it's time to do the resistor now. So we tap into the grey. We put a resistor in the middle, and then that goes into the positive of the mouse switch, and then negative will simply go into the negative from the mouse switch. So what that will look like simply is, that's a transistor. There's a 220 ohm resistor. That'll go between that and that. That'll go to a connector. We're just gonna actually use a quick connector. So we can actually quick connect to the mouse if we want to take it in or out to make our life easier. And this will be really handy if you ever wanted to solder into a different mouse altogether. And then yeah, we'll have earth for the mouse switch. So we'll have 3.3. The grey is going to be 3.3 volt from the mouse switch. And then the black is going to be earth from the mouse switch. Should go to earth here to the normal earth. That's pretty much it. Right, so that's what that looks like. Now is the hard part. We're going to have to get our multimeter. We're going to have to get our mouse cable. We're going to have to get our mouse. We're going to have to take apart the mouse, plug it into the PC, and we're going to have to find out which one is earth and which one is the 3.3 line. And the earth is going to need to go to black, and the 3.3 line is going to need to go to the grey. And we're actually going to have to solder these onto the switch itself. So it's going to be quite tricky, this one. With the SIP light, it's kind of difficult to get to the mouse switches without taking it apart, but we might be able to do a dodgy and just be able to solder where we need to. So we're going to go plug this into the PC now and find out which one is earth and which one's the 3.3. And I'll do my best to record this. So I'm going to use, I've got the multimeter in volts. I'm going to put the negative to just where the kind of housing of the USB is. So that'll be earth. So I'll hold that down there. I'm trying to move my hand out of the way so you guys can see. It'll be difficult. Okay, and then the middle switch, there's 3 here, right? On a switch, usually there's just 3 connections. The middle one here, it's very hard for me to do this on camera. That's someone holding the camera. So see how we've got 2.6 roughly volts coming through that? I need to get a better connection. It's very, very hard to do. I'm trying to show you guys this. So yeah, 2.7 roughly. When I click, when I hold down click, it disappears. When I let go, it shows up again. When I click, it disappears. So we know that's our 3.3 line there. So now we just need to find earth. So the middle one here on the Logitech, very, very middle one, that's our 3.3 line. The grey one. Once again, using my multimeter, we've got it on the resistance line. I can't remember what that one's called, but it's like check resistance for earth or something like that. Once again, I'm going to put the black one on the USB housing for an earth. And then if I put the red on the other housing of the earth, we should get a little bit of resistance that's normal. So we're getting point, very hard for me to do. Very, very minimal resistance there. So that's earth, right? Now we'll do it on the mouse switch, so the one on each end. That's an earth, and then it looks like the other one on the other side is an earth as well. Yeah. So I'm just going to wire the earth one to the very, very first one, which would make my life easier. There are some mice I've noticed that, not this one in particular, but there's some mice that the third one actually won't get used at all for anything. But with this mouse, it looks like the first one is earth, the middle one is the 3.3 volt line, and the last one is the earth as well. So now there are two things I'm going to do because this is a wireless mouse. Well, one thing I'm going to do because this is a wireless mouse, I'm actually going to take out the battery. So that should be pretty straightforward. Should be able to just pop this out. So the battery is out. We're going to need to use the mouse in wired mode simply because of the earth for the switch. And another thing we're going to need to do is we're going to need to tape up the sensor itself. So the mouse is always going to feel like it's in the down position, like down on a pad. Because if you don't, it depends on lift-off distance and stuff, and some mice behave differently than others, but you can actually get higher click latency, like much higher click latency, lifting your mouse up and clicking. It's just how a lot of mice work. So Final Mouse's XLAT tool, they do that too. They just tape over the center. So I'm going to be putting some black electrical tape over the center. There we go there, we've got our black tape over the sensor. So yeah, that's a pro tip if you want low latency on a mouse. Try to keep your mouse down when you're clicking and set the lowest lift-off distance as possible. And to make my life easier, I'm actually going to drill a big hole right there so I can feed the cables through there. So I can actually put this back on. So here's my drill, wish me luck. So drilled the hole and I've just folded over this wire a couple of times to make my life easier when I solder it to the very first one there. Now I'm not gonna lie, this is probably one of the most frustrating things to solder. So what I've actually done is I've put a bit of tape there to just hold it in position while I can solder it onto that part of the switch. Very, very frustrating. May have butchered it a little bit. I was really happy with the first one, the earth, the black one. But unfortunately, I think the soldering iron got a little hot on the second one, but at least does the job. So we'll put the mouse back together and we'll actually test if this is actually working, if it's soldered in correctly, because if we touch these two together, it should click. Right, all done, plugged in the mouse. Looks like it's still working. That's awesome. So now I'll just boot up, I guess, double click test on Google. Just search something for that and we can just test if touching these two together actually clicks. All right, I'll try to get the camera to focus. So it indeed is working. So we know we've got a good connection, which is good. That's just a double click mouse test page, just found it on Google. So when I earth these out together, it actually clicks the mouse. Now for the photo diode, it would probably be a good idea if you're not going to be using or making a custom housing. We could put some like black electrical tape out the back, mainly because we don't want to allow any light, sort of external light, get into the sensor. So that's the sensor right there that'll pick up any changes in a light flash. And we've just got to make sure that, yeah, we've got no other kind of light getting to that so we can get accurate readings. So I've just done a quick dodgy job. Should do the job for now. you guys will probably be able to do a better job. Now we're going to need to get our double-sided tape, the clear stuff, cut that a little bit off, and we can just put some here so it's got something to stick onto the monitor. We have it, and the soft gel double-sided tape's there, so they'll actually be able to stick onto our monitor now, and that shouldn't let too much light in. The little electrical tape. All right, let's grab our cable. We'll get ready to plug it into the Leonardo board. For now, we'll just leave the mouse unplugged, but we will plug it in very shortly. Just got the little setup here. This is what it roughly looks like. All right, we've got Arduino plugged in. We've got a green light, and it's definitely plugged in there. It will show up as like a COM. Sometimes when you unplug it, replug it, it might show up as a different COM. And I've also stickied the photodiode to the monitor with a double-sided tape. So now we're going to have to go to the website, Arduino website, and go ahead and download the software. We're going to need the software so we can flash the latency test code onto this. And there's lots of different configs, but there are also configs where this doesn't need to be plugged into the PC at all. We could just simply power this through like a phone charger or something. That'd be fine, but we need to flash the software first, so it has to be plugged in first. So, which is really nice of a bypassing anti-cheats, doing it that way, flashing the mouse test software, where it will just auto click, and then plugging that into a different power source, so an anti-cheat can't see that you've got something plugged in. Because a lot of anti-cheat software do not like boards like this, because people can use them for macros and cheating and stuff like that. So yeah. So go ahead and download the Arduino software. Hopefully you guys won't need a driver, or the software will come with a driver. I have been on some Windows builds in the past where it didn't pick anything up and it wasn't in Device Manager. So if that happens, you might need to go look at finding a driver for it. But most of you should be okay, plug and play.
Let's go ahead and install that now. Let's go ahead and open it up. We're going to need a library. Okay, so this is, remember my stuff from before. So just ignore all of this. Most of you will probably just be a completely empty sketch like this. Okay. So I want you guys to go to library, because we're going to need an extension. Just on the left here, click library manager, and we're going to need, up in the little search thing, U8G2. So we want U8G2. Go ahead and hit install. Go ahead and install it. Now we'll have the library that we can use. We just need this library for the configs itself. Now I haven't uploaded the configs to GitHub yet. I will do that shortly. But it will roughly look like this. So I'll quickly go over the configs real quick. So the Arduino ones are going to be for when you actually have the device plugged into the PC. Right, so like you'll actually have it physically plugged in. So if you actually don't want to use a mouse itself, you don't have to use a external mouse to do this. You could just use the device itself, and that's cool for some games and some tests, and it will sometimes makes life a little bit easier. But just because the game's with anti-cheat, it's also nice to measure the latency with the mouse as well. I prefer using these configs, and I'll talk about those shortly. So yeah, these are for when the actual the Leonardo is plugged into the PC. This one will just click every so often. So I'll open the config just to show you guys. This will just continuously click basically, and pull out a latency measurement, and it'll just indefinitely click. And then the console will just constantly click the console. So when you flash these, the PC actually sees the Leonardo as a mouse device, right? And the Leonardo board will do the clicking. Anti-cheat do not like it, right? So you actually don't need a mouse plugged in, and this will just constantly spam the console button. I was using that for some games that didn't have a latency flash, and using the console bar to sort of roughly measure latency. But you really don't want to be doing it that way, and I'll explain a little bit later what's the best way to measure latency, because muzzle flash or menu items aren't the best either, but we'll talk about that later. This is for paint, a simple paint test. You can kind of test latency of paint in the Windows compositor. So in Paint, if you have the first one at white and the second one at black, left click is black, sorry, right click is black, left click is white, and so it'll just constantly cycle through this. And when you click and then it goes white, because that's what we essentially need to do for this latency tool. We need to click and there needs to be a flash or something white so it can measure that latency between the click and then the white. So yeah, that's what that's for. The Arduino board will, so just to sum it up guys, these, the Leonardo board plugged into the PC will click for you or do whatever command for you. These, when you flash them, you don't need the Arduino board plugged into the PC. It just needs to be, it can be powered externally and the mouse will do the clicking for you, or you can manually click the mouse with the manual one. So yeah. And the UE4 is specifically for Unreal Engine 4 black and white test. It's really handy. You can get it from Apogee Google. Just go here, go software. He's got a couple of really cool ones here, but we just really want the black and white. So here it is here, black to white. So this will simply press B and then W. And when it presses W, it'll measure for how long it takes for the screen to flash and put out a latency. So we should see that in the UE4 one. We should see B and W. If we scroll down here, and I've tried to put some notes in here so you can see what's going on. So U8 G2s for the screens, mouse H. So this is actually emulating a mouse and a keyboard. The Leonardo board is with this config. So see, we have a send keyboard B key, and a little bit further down we'll have a send W key as well to cycle through it somewhere in here. But yeah, you guys get the point. It just does it for you. So you press the button on the latency tool, and in here it'll just constantly click. It'll constantly click B and then W, flashing black to white, black to white. So this kind of a test is really cool for measuring something like G-Sync latency or you know, monitor latency or overdrive, you know, different monitor settings and stuff like that. Mainly like major graphic settings, stuff like that. You can do lots with it too. You can change render resolution. You can change, you know, VSync. You can do all lots of really cool. You can change lots of stuff just with the UE4 commands or the console command. Yeah, this is a really nice one. Now, mouse auto click will just these ones you need to have the mouse plugged in, right, to the Leonardo board and the mouse plugged into the PC. And once you flash them, you can actually, you don't have to have the Arduino board plugged into the PC. It can be powered externally. Like again, that's good for any cheat. Auto click is just like when you push the start button, it'll actually auto click the mouse for you every so often, and it will do it in random intervals too. So it doesn't flag any anti-cheat, which is quite nice. So it'll just constantly do it. So you can work out as many averages as you want. It'll just keep going and going indefinitely, basically. There's a bit of code in here to just randomize the time that it clicks, so it's not exactly at the same time, because sometimes anti-cheats can pick it up as an auto clicker. So that kind of takes care of that. There's a random delay, which is cool. Now which one are we up to? The console click. This one here, you guys can ignore that one. That was just something I was doing with the G303. I soldered in a switch for the G shift button. So I could actually automate it for doing console command. So I put G shift to the console key, but you guys won't need that one. And the macro click, I can't remember, probably does the same thing. You guys probably only care about the auto click and the manual click, and the manual click will simply allow you to do it yourself. So you'll just have to sit there and manually click the mouse and get as many samples as you want if you want to manually click it. But my recommendation for all of you would honestly be using the auto click. This is the config that we should load. And there's always going to be a delay with the Leonardo board, right? So add a delay, and you could actually time how sensitive this photodiode is. Now, this photodiode isn't perfect. There are better options out there, and I'm going to look at making one with a better option later, but this is good enough to show latency values. Pee-wee made a cool little PDF just talking about consistency validation, but basically that you can get you know, variance between 1.2 milliseconds with this tool. And it's sort of always like that. So you just need to, sometimes you just take tests with a bit of grain of salt when you see a 0.2 of a millisecond difference. Generally, like over that, you want to consider that a difference. But yeah, I fine-tuned these to be as quick as possible without throwing any errors, because if you tune it too fast, you see the latency here, we've got 2.3 milliseconds if it's tuned like that, and that's just how sensitive the photodiode is. You know, it's adding latency to it, right? So at the moment I'm using this here. That's the best that I could get it, and that's the lowest latency I can get without you know, any light in the room triggering anything. You get a lot of errors with these. So I'll probably be able to tune this down later when I rebuild the tool with a tiny 4.0 and a completely different sensor than the photodiode. But for now, this is just what we're currently using. So expect, you know, 1 millisecond of latency added onto the test, plus whatever the Leonardo board is as well. Okay. Just sort of just mention that, right? And most of you, I'm going to want you guys to use the NVIDIA Reflex Flash in the game. It's very, very accurate and much easier than using muzzle flash in a game. Muzzle flash is a nightmare. If the game doesn't have Reflex, or you can't enable the NVIDIA Reflex Flash through GeForce or NVIDIA app, you're going to have to look at using muzzle flash instead, really, or just some kind of a trigger that makes a flash. Now, honestly, muzzle flash is probably your best bet, honestly, because there's a lot of other things in the game that can be slightly delayed animations or random, depending on server. But if you do want to do that, you might need to dive into this, and if the results are all over the place so you can't really get a reading, you'll probably actually need to dial these down, maybe something like this or this. But if you're going to be using the NVIDIA Reflex Flash, which is, I'm going to show you guys probably both today, but you know, it's tuned as best as it can be. By the time this video comes up, all this will be on GitHub a little bit more well organized, obviously. But for now, the first config that I want you guys to load would probably be the UE4 config, just with your Arduino board doing the BW, just to make sure it works. And go ahead and download the Aperture Creel Black to White software. Now, what we need to do is we need to flash the code to the board, right? So we're going to do that now. You go to File, and then you go to Open. Okay. And you'll need to find out where the config is. Now, the config needs to be in a folder, otherwise the Arduino software kind of has a big cry. So actually, the way it needs to be is like Arduino UE4 and then the file. So if you're going to move it somewhere, it needs to stay in its folder, just the way it is. Sort of like that and that. And it needs to be like that, just the way that the software works. Right. So I'll let you guys know that. So we just click Arduino UE4 and then that, and then open. And then if there's another window, your original window is open, you can just close that. Right. And you're going to be very, very careful that you don't accidentally type in here and save it, right? Because you can screw up the code. That's very, very important. And we're going to need to make sure we've got our, you know, board plugged in and we've got the right COM selected. So we do not have the right COM selected at all, right? Because the COM was something different, wasn't it? It was, I remember, COM was actually COM4. So we're going to need to go up here and we're going to need to select Arduino Leonardo COM4. We'll do that. Now, if it doesn't show up in here, there's a problem. You either need to try a different USB port, or you need to try to find drivers for the board and then restart, or you might, worst case, have to select other board and port and have a play around with it in here. But most of you hopefully won't have to do that. So you click that, and down the bottom here, it'll say it's recognized. So it's recognized. The first thing you want to do is actually verify the code and make sure everything is okay. So we hit verify. We'll say compiling sketch. And just leave the mouse unplugged for now. I mean, the gray and the black cable don't plug into the Leonardo board yet. Okay, so this is all good. And then we'll go ahead and we'll click upload. So now it's going to upload to the board, and you will actually see something pop up on the screen if we wired everything up correctly.
looks like it flashed okay, but I got a bit of an error with the screen, so I will fix that and look into it. But it looks like we have a display here, which is really great. So let's test if it roughly works. So I will press this button, which is the start button, and it should show B. There it is there. So yeah, press it in, press it out, and it said B for black. So push it in, let go, push it in, let it go. Yeah, sorry, I think this is the way this is coded, is because I redid the code because now his new black and white test is actually click. So you don't have to press W, it's like click and then B for black. So that'll be click and B for black. Oh, hang on, let me click there because I'm actually not in there. So it'll be click when I push in and then black when I let go. But obviously when we just push it in all the way, it'll constantly cycle through click and black, click and black, click and black, click and black. So it looks like it's working. As you can see here, we got the min and max, but min and max is on both screens. So it looks like I'm gonna have to fix that code or find out what I've done wrong. But let's see if we actually get a reading. So open up the black and white test. And that looks like it's ready to go. Go ahead and press the button. Hold the button down, see if anything happens. Yeah, okay, it's working. And it's putting out a value, which is awesome. So it'd be minimum latency, maximum latency. But that screen is supposed to show something different. So I better go figure that out now and be right back. Oh yeah, it's actually working. We're getting a latency measurement, which is cool. Okay, let's test our reset button. So I press the reset button and it should reset the screens back. Cool, so I just need to fix some code with the screens. Maybe I need to put that screen on that screen. I'm not really sure, we'll see. And I'll be right back. All right, so it's fully working, but, and this isn't actually any error code, that's totally normal. I haven't done this in a while, I totally forgot. So the issue is we have the same image displayed on both displays. And what I didn't realize is we actually need to change the address of the second display. So I'll see if I can zoom in here. We actually need to change the address on this one, only one of them, which is going to be the right one. So that's the left one, this is the right one. We need to change the address from 0 times 3C to 0 times 3D. So we're actually going to have to take, see if I can get something to make it a little bit easier to show you guys. We're going to have to take that one off, unsolder that one. I have to unsolder that little resistor and then bridge it between here, which is going to be quite painful. So that's how we're going to change the address. That's why it was displaying the same thing on both displays, because they were both the same address. So I'm going to go do that now. All right, that was probably the hardest thing I've ever had to desolder and resolder. So let's plug it in and hope that it works. It's definitely not a perfect job, but let's just hope that that works. And would you look at that? That actually works now. Awesome. Okay. So what I'm going to do now is I'm going to plug in the mouse. All right. I'm going to plug in the gray to the gray and the black to the black, and then we can go in and we can go upload the mouse auto config and see if we get see if that works. Actually, before that, let's try the paint test. So I can show you guys something a little different. So I'm going to go to the paint, I'm going to open that. I've got my Latency board plugged in fine. We've double clicked it so we don't need to go open. I'm going to make sure we select the board. It's in COM4. I'm going to verify the file. We'll verify the file. Wait for it to just verify and make sure everything's good. Then we'll go ahead and then we will upload the file. We'll wait for that to finish. Uploading. You should see these screens change pretty shortly. And there it is there. We have Erjudo Paint. So what I'm going to do now is I'm going to close this. We don't need that anymore. I'm going to open Paint. I'm going to set the first one to white, the second one to black. Then I'm going to click the little change color. Just check that we're working. Cool. So if I press left click, it's black, right click, it's white. Okay. Then I'm going to drag this window over, if the camera would stop auto-focusing, over the actual sensor itself, like that. And now, let's see what happens when we press the button. So we'll press the button in. We'll just press a reset because it seems to be bugging at the moment. Maybe we need to set the black first. Oh, that's right, because I didn't have my mouse cursor. I've got to have my mouse cursor over it as well. That makes sense. Okay, let's press the button in. And here we go. Now we have a reading. I don't know why my screen is like a little bit yellow on the top right. That could just be because it's like a cheaper brand one or something. So now we're actually getting a latency reading. We've got minimum and maximum latency. The real values we want to look at is current, which is at the top, average, which is in the middle, and total. So that's quite a bit of latency, but that's because we're at 240 FPS with the horrible Windows compositor that is on 11, plus whatever delay Paint might have. But yeah, that's doing its thing. Now that is the Latency board that is clicking for us. We actually don't have the mouse plugged in right now. As you can see, it's not plugged in. Now let's go test a config with a mouse. So to stop the test, right, we would unclick it so it's in the up position, and then we would want to reset the stats on this screen like that. Boom, it's reset. Okay, we plug the mouse in, got the grey and the black and the black. Let's go to mouse auto click because we want the mouse to do the clicking for us. Mouse auto click, we'll open mouse auto click. Let's go ahead and select the board, which is now in COM 7. We'll verify it. We'll upload it. Eventually we should see these change when it's uploaded. Mouse auto, awesome. So now that we've flashed that, we can actually close this. We don't need it anymore. We can actually unplug this Latency board and plug it into a phone charger or just something separate from the PC, just so the PC can't see a COM device connected, especially for anti-cheat, right? So I'm gonna go do that now. Lucky for me, my power board actually just has a port I can plug it into, so that actually won't be plugged into the PC. Done. So now it's plugged in and powered separately from the computer, and the computer only sees a mouse connected. So I'm just going to show USB tree view here, guys. So that's my OP18K, which is just my main mouse there. That's the Logitech mouse here, and normal clicking works, right? But we're not going to be using manual clicking with this config. And then yeah, I've just got my wording plugged in as well. So now we can actually use this, and when this is in the on position, it's going, the Arduino board is going to automatically click the mouse for us, so we don't have to sit there like an idiot constantly clicking. That'll give us some readings. So now we've got to boot up a game with either muzzle flash or the reflex flash. Now I'm just going to use the reflex flash because it's going to make life a lot easier. Down on the bottom left there should be statistics, and down the bottom should be reflex analyzer. We want to turn that on, so that will enforce games to use the reflex box flash for the LDAT tool. So that did not work. I should have the reflex flash, so I'm going to quit the game. We actually can turn the overlay off entirely. There's a little trick to it, right? The trick is you boot up GeForce Experience, you enable the overlay, you enable the latency flash option, and then you can disable the overlay, and it'll work that way. But if you restart, you need to enable the overlay so it toggles on, and then you can disable the overlay. It's kind of hard to explain. I'll show you guys.
It looks like they might have gimped the software, but before I make that conclusion, I'll uninstall the driver. They've gimped the overlay completely. I've got the same problem here. Let's see if I can find a way to get the reflex flash to work through in the NVIDIA app. All right, so after a lot of painful hours, I was not able to get the reflex flash to work at all. I tried everything. And I guess this is the problem when you rely on software technology. Now, I could have probably rolled back to an older NVIDIA driver and then used GeForce, but I'm fairly stubborn. So after hours and hours and hours, I figured out a way. There is something called a NVIDIA Streamline. And you guys can download this and I'll link it. And we can actually enforce a reflex flash with one of their programs, which is great. Here's a little bit of information on it. And this took me a long time to figure out. But basically we can just run reflex setup bat, and it will enforce the reflex flash. And I did a lot of testing today. I basically found out that you don't need NVIDIA app installed to make this work. You don't need GeForce installed to make this work. You don't even need the SDK, FrameView SDK at all, even though it says you do. And you can actually delete a bunch of stuff in the reflex folder. So nothing runs like present mon and all that other rubbish, because all we want to do is enforce that the latency box flash works. I even tried like finding how the reflex file works. So we'll just go ahead and download the file now so you guys know what I'm talking about. So we'll just grab the latest streamline. Go ahead and code download zip. And while you're at it, go ahead and get NVIDIA profile and expector, and I'll show you why shortly. We'll grab those two. All right, let's go ahead and extract those two. Pretty straightforward. So to make our life easier, I'm just going to create a folder, and I might just share this folder on GitHub just to save you guys some time. So I'll call it Force Reflex Flash. Put NVIDIA profile inspector in there. And the streamline folder. Here's the streamline folder. We don't need any of this rubbish. There's probably some good stuff in here, but all we need is tools. All we need is utils and then reflex folder. Open that. And so basically we can enforce a reflex flash. Their instructions are install FrameView SDK and run reflex test setup.bat. And what that does is just runs this program called reflex test, just with the bat file, which is just that and that. Now I've done a little bit of digging on this and I'll explain in a little bit. All we're going to need is reflex test, cleanup bat, and setup test setup bat, and put that in these folders. And we can literally just go like delete everything else because we don't need anything else. And that way, if we do it this way, we won't have present mon running in the background. We won't have NVIDIA files running in the background in Task Manager. So this is because all we want to do is force the reflex flash, right? And as far as for these, we actually don't even need curve because we're not going to be using that. And I'll just clean that up a little bit there like that. That's all we really need. You can't just run reflex test.exe. It won't work. You actually have to run it through the bat, which is annoying. And this file will have to actually be in the folder. But it's really cool. We don't actually need to install anything at all. And yeah, I did test this without everything, like without NVIDIA app, without SDK, without everything. Multiple DDU installs. I even tried to decompile this program with some software to extract it, find out what it does, find out how it works. I tried registry changes view to see if anything was getting changes in registry. I tried going NVIDIA profile inspector and the NVIDIA DRS files and also the DLLs and all of that. Like I've spent hours on this, like a long time, to then discover that basically this program is somewhat encrypted and it is actually just changing a memory address to enforce the latency flash box. And so the latency flash box, if a game has reflex in it, the latency flash box will can be toggled. But how that gets toggled is a memory address, which gets wiped on a restart of a PC. So this will enforce the memory address and we don't have to rely on GeForce or NVIDIA, which is great. But this got me fairly excited and I thought, what if we could technically make this work on an AMD card? And in theory it would work, but it just didn't. So I got a buddy of mine, Chili Ride, to test. Gave him some instructions on what to do. And yeah, it just didn't work for him, unfortunately. So I think you actually physically need an NVIDIA card to change that memory address. It might be some way the file is coded, the test reflex file is coded. So that's super annoying. But I was able to get it to work with an overlay, which is annoying. But I'll show you guys how to get rid of this overlay entirely. But yeah, he wasn't able to get it to work. So it looks like no luck for AMD cards, unfortunately. But there are some games that do have an option in the config to force the reflex flash. There's not many, but there are a few. But doing it this way with the memory address is much better. So because we've deleted all the other files, when we run reflex test setup.bat, it'll actually just open and close, and we don't actually need to do anything. But we will get an annoying little overlay on the top left, which I don't like. So I want to get rid of that, right? Which is this thing here. I like to get rid of that. So it does change three things in the NVIDIA Profile Inspector, or should I say the NVIDIA DRS files. What it'll enforce is the overlays, which is kind of like a really annoying. So see how there's nothing there, right? If I run reflex test setup.bat, it basically opens this, but doesn't have a little command prompt window that'll stay open like it usually would, because we deleted all the files associated with it, because we just want this to change the memory address so we can get the reflex flash forced. It changes these three values here. I'll just open this one, make it a bit easier, but these ones here. So you can go ahead and you can turn these off because we don't want the indicator overlay at all. We just want the reflex flash box. Press apply. And now when I open up a game, we should have the reflex flash actually forced on, as it's changed the temporary memory entry. There it is there. We've got a little flash box. There it is there. Then if I want to get rid of it, we can either restart or we can do reflex test cleanup.bat. And if I open up it again, there'll be no box. Now, if you want the overlay, you could just leave Profile Inspector. You could just run reflex test setup.bat, open the game. But you will have a very annoying overlay on the very top, and it will stay over like frame view or MSI Afterburner or anything. So I actually find it quite annoying. See here. And I don't really need that. I just want the box flash to be there. So I'll purposely go in an inspector and turn it off. And so after every reboot, you kind of have to redo this, right? If you want the box, reflex box on, because it's actually changing a memory entry. It's not changing anything. So this is basically changing some things in the DRS files, but that's just for the overlay, which is the ones we just turned off there. And it's also changing a temporary memory address to force the reflex box on, which is basically what, you know, the NVIDIA app and GeForce are doing, but they're not working at the moment. So at least we have an option. Okay, we got it working the way I like it. And the reason why I like the fact that we've deleted the other files, if you see here, we don't have any other NVIDIA apps open, just the driver, right? You could basically not have GeForce installed. You could not have NVIDIA app installed, and you could not have FrameView SDK installed, and it will still work, which is great. Now, I did try to like dissect this and find out what the memory address was and see if we could just make it in a script, but I just had no luck. So maybe you guys, if any of you guys are smart enough, maybe you'll know how to do that, and just let me know in the comments. And I wanted to automate these settings getting turned off, and there's just no way to do it with a NIP file, because NIP files will change everything else in your NVIDIA control panel. And I didn't really, if someone had G-Sync on and then I forced it off, that'd be annoying. Or like if someone wants to test and use different settings, I just figured you'd be better off just manually going in Inspector and just turning those values off there yourself. So yeah. Right, so let's test this thing. Now that we finally got the reflex box enabled, anytime we click. So I'm gonna have to stick this right where the box is and just make sure that it's covering the sensor entirely. Right, we don't want any light getting in there at all. You guys, like I said before, you guys will probably be able to do a better job at that. So I'm just gonna stick this right here. All right, we're actually in a match. We've got multi-frame generation on in Oblivion. Remastered, we've got our little photodiode stuck there. Let's go ahead and do the test. So to reset,
press that, but we don't need to press reset at the moment. Mouse is plugged in and everything. Let's press this. And as you can see, it's doing its thing. The mouse is auto-clicking for us. The frames. And we're getting some latency readings. Well, those latency readings aren't too good because of multi-frame generation. Let's go ahead and turn multi-frame generation off, or just frame generation, which will turn multi-frame generation off. Supply there. And then get out of the game. And now our frames natively in 4K with some higher settings. It's about 110. Let's go do the test now. I've already pressed reset here, so. There it is there. And that's our overall latency. So that's the latency of the mouse. Unfortunately, latency of the board. And then obviously whatever's tuned to make this sensor accurate. We don't want to over-tune it because otherwise we won't get readings. The latency of the monitor and the whole system at 110 FPS in native. So that's a great example of showing you guys how to set up the latency tool properly. And to stop it, it'll just indefinitely keep going, right? But to stop it, done. To reset it, done. That's how it's done.
All right, let's boot up something a little bit like more or less a lot more well optimized. So you guys can use this for any game that has reflex built in. Any game that has reflex built in will have the flash built in. We just need to trigger it, right? So I've got frame view open and MSI Afterburn open so we can see more of what's going on. But more so we can compare frame view PCL on the top left versus the latency tool. So let's go ahead and we'll just do a whole bunch of runs. There we go there. All right, so PCL is showing all the latency except for the monitor latency and the mouse latency. And the external tool right here is showing everything, which is awesome. So we can actually compare a setting as well between the two. But it's just really cool to have the external tool because you can kind of see everything. But honestly, you really only need to use frame view for PCL. When it comes to testing most things, testing other things like, your monitor or different mice latency is kind of handy. So how many runs is that? 71. We'll stop that right there. So 5.6 on frame view. And the average is 9.49 on the latency tool. So let's go toggle something that we know that adds quite a lot of latency. We'll do two things to just gimp things. Oh, we'll do a bunch of things. Let's just disable reflex. That'll make latency worse. Let's enable frame generation. The game doesn't crash on me, hopefully. Okay, it didn't crash on me, thank God. And let's just max the render resolution because we know that'll add latency as well. So technically that'd be like 5K. All right. And that's affected our frame rate quite a lot. Latency's come up to 19 milliseconds according to frame view. I'm going to press the reset and then start button. Hopefully that camera hasn't gone out of the little screen, hasn't gone out of the camera. Let's see a little bit. See if I can fix that up. Best I can do, lads. So what did we do? We did roughly 74 before. So yeah, guys, really cool tool. hopefully you guys, if you're going to give it a go, you don't find it too much hassle to build it. And hopefully this NVIDIA Reflex file will always work in the future and you guys won't run into any headaches at all. And we'll have to see. It'd be really nice if developers just added a graphic option in the game to just, you know, change it, but you know what's crazy? I've done everything that I can to try to ruin latency in this engine. It's still better than Oblivion because Unreal Engine 5 is just so bad. Okay, that's enough. We've done a lot more than 74, 10 more than 74. So yeah, average 21.44. That's the value we want to be looking at. And your 19.5 on PCL, but that's not including the mouse latency or the monitor latency. So yeah.
Right, so now I'm going to place all of this into this to make it a little cleaner. We've already got the glue gun on, ready to go. There it is there, all put together, ready to go. I did decide to cable tie the mouse and the photo sensor wire just in case it got pulled at. Right, we're ready to go. Right, this is it here, all set up, ready to go. Got it in its little housing. So that's connected externally through the power brick. I've just hidden the mouse back here. And the mouse is connected to the PC. So there we go there. Now I have it set up on the stream PC. It's just with a little camera. So you can kind of see what's going on. Pretty cool.
Let's say you wanted to solder the mouse in, but you actually wanted to play with it, or you wanted to manually click it. I think the only config I haven't shown you guys is the mouse manual click. So we'll go ahead and we'll load that now. So that's loaded. I'm going to have to plug my board in right now, because at the moment it's plugged in the power brick. So I'm going to plug it into the PC. Right, so we've plugged it into the PC. There it is there. Now we need to just go ahead and select COM4 or verify. Right, it's done compiling, and then we'll go ahead and we'll upload it. And then when it's flashed, if it flashed correctly, it should say on the display mouse manual, I believe I named it to. Yep, mouse manual.
Now what if we test something a little bit more different? We'll test Counter-Strike. At the moment it's flashed, it's at mouse manual. So I'm just going to unplug it from my PC here. Now that we've flashed it, I can plug it into the power brick here. But yeah, phone charger will do too. And we'll go boot up some CS2 and we can manually click the mouse. Right, we've got CS2 launched and the flash is working correctly. Everything's lined up. So the way this config works is we actually need to press the start button first. Then it'll be listening for mouse inputs. So we'll start clicking here. So technically you could wire this up if you wanted to. Now this game looks like it's bugged out because those readings are not right at all. I think it's the way I was pressing on the mouse switch. If I hold it down, it seems to lag a little bit. So you're gonna be wary of that. So let's stop it. Reset it. Now I'll start it and I'll just be really quick when I push down on the mouse. All right, ready? That's more like it. That's about right. So that's the game latency, monitor latency, and the mouse latency. It's pretty good. So we are in 4K and I don't have the FPS counter overlay on, but I imagine that would be at least 600 plus FPS. But just be wary of that using the manual method. Don't hold the switch down, at least for some mice. Okay, it looks like it was about 1000 FPS. So yeah, you could technically wire this in and permanently use the mouse, but I think it'll get a little bit annoying with the cable. So I'm actually gonna flash this back to mouse auto and just leave it set up like this. Whenever I need to do a test, it's very, very easy. I can just simply put this on, and away I go.
All right, lads, the GitHub is up and running. It should be easy enough for you guys to just hit code download zip. You can grab the whole thing. We've got the configs in here, ready to go. About me for the configs. Got the software needed. I've added this in here to make your life easier so you don't have to do it yourself. And I've just added links to those downloads just to make life easier. Wiring diagram for you guys. And yeah, it's the whole thing here, the parts list and everything that you need. And I'll update this soon when this video goes live. Enjoy and happy testing, guys. Hope you found the video useful.